Hello and welcome to my course. My name is A.T. Imam. I'm a senior lecturer at the Department of Mathematics, Ahmad Bello University, Zaria. This is a course designed for postgraduate students, both MSc and PhD students who are preparing themselves for doing a research in semigroup of transformation. So this is the first lecture of the series, and in this lecture we are going to give an introduction of what this course is all about, introduction of semigroup of transformations, and also some background on transformation semigroup. So a semigroup is a set together with an associative binary operation, and the theory of semigroup lies at the heart of modern algebra and theoretical computer science, offering a rich framework for understanding composition and structure in abstract system. As an algebraic structure consisting of a non-empty set equipped with an associative binary operation, a semigroup generalizes the notion of a group by relaxing the requirement for inverse and identity element. We all know that a group is a set together with an associative binary operation that has identity element in which every element is having an inverse. But for a semigroup, you only need the requirement of the binary operation being associative. So it actually do not require that the semigroup must have an inverse or must have identity element. So the requirement of inverse and the identity element are not necessary in defining a semigroup, and this gives it a very simple structure. So despite the fact that the definition is requiring just a very few axioms, semigroup exhibit deep and varied behavior that intersect with numerous areas of mathematics and its application. Among these, the most illustrative and exclusively studied classes of semigroup are transformation semigroup. The semigroup of transformations are semigroup whose elements are transformations or functions from a set to itself under the operation of composition. So these are the most studied, and they find application in many areas of mathematics and even outside of mathematics. So, and this is actually the semigroup that this course is all about. These are the classes of semigroup that this course is aiming to study. This semigroup provide a concrete and intuitive model for semigroup theory and play a central role in automata theory. So we are talking about transformation semigroups here. And actually, they provide a concrete model for semigroups. So generally speaking, every semigroup can be embedded in a semigroup of transformation, which means you can model every semigroup as a semigroup of transformation. And this transformation semigroup, they have a crucial role in automata theory, in language theory, combinatorics, in functional analysis, in dynamical systems. So there are a lot of applications which we are still going to talk about in this course. Applications of this transformation semigroup. The study of transformation semigroup is not only foundational but also pivotal in connecting abstract algebra with computational and applied sciences. For example, the full transformation semigroup. The full transformation semigroup on a finite set, it forms a key object in understanding symmetries and structural properties of finite state machines. we are going to discuss all these issues in detail. Similarly, partial and injective transformation semigroups are essential in semigroup representations and the study of algorithmic behavior. So these classes of semigroup are very important. And so therefore this course, which we call Transformation Semigroups and Applications, provide a rigorous and structured introduction to the theory of transformation semigroups, with a special focus on their algebraic and combinatorial properties. We begin with an understanding of the structure of transformations of a finite set, and then explore Green's relations, ideals, idempotent, and congruences. These are generally concepts studied in the theory of semigroup. So we are going to look at all these concepts within the context of transformation semigroup, in semigroup of total, partial, and injective transformation. So actually we are going to pay attention mostly to three classes of transformation semigroup. That is the full transformation semigroup, also called total transformations, the partial transformation, and the injective, that is the one transformation of a finite set, and we will also later look at infinite sets. Further, the course explores the connection between transformation semigroup and other branches of mathematics, such as topology. We will look at the connection between transformation semigroup and topology via continuous transformation, and also functional analysis via operator semigroups, and computer science via automata and rewriting systems. So objectives of this course: by the end of the course, participants should be able to analyze the structure and classification of transformation semigroup, investigate Green's relations, ideals, and idempotent in transformation semigroup, explore connection between semigroup theory and automata, logic, topology, and computations, apply transformation semigroup theory to solve problems in mathematics and computer science. And students should be able to engage in independent or group research projects on transformation semigroups. So here we look at the course content or outline of the course. The course is going to consist of basically 12 chapters, and in the first chapter we are going to cover basic notions on transformation semigroup. So the first and second chapter will actually be talking about transformation semigroups, and in this chapter will have about 3 sections. The first section of the chapter will be talking about the definition of a transformation of a set, and then the second section will define the notion of the full transformation semigroup, and then we'll look at the structure of a full transformation, structure of the individual element in the semigroup of full transformation of a set. And then the second chapter will continue a discussion on transformation semigroup, and then we will now under the chapter talk about partial transformation, and then we'll also talk about injective transformations, order preserving and order decreasing transformation. All this will be defined under the second chapter of the course. The third chapter will cover Green's relations. In this chapter, the first section will present definition of Green's relation in general, and then we will talk about characterizing Green's relation in full transformation semigroup in both finite and infinite cases, and then we'll look at the structure of the finite full transformation semigroup. We will study this structure via the characterization of the Green's relations. And then the fourth chapter, which will continue the discussion on Green's relation, will look at equivalent classes and their combinatorics, equivalent classes of the Green's equivalences, and then we'll also look at counting element in the equivalent classes and the number of classes and so on and so forth. So we will also look at application in classification and enumeration. And then the 5th chapter will start talking about special elements in transformations semigroup, where we will look at idempotent. Then we will study idempotent in full transformation semigroup. We'll also look at product of idempotent in full transformation semigroup. And then in the 6th chapter, we'll continue the discussion on idempotent, but this time around in partial transformation semigroup, and then product of idempotent in partial transformation semigroup. The 7th chapter will look at a special class of element called nilpotent. So we'll look at nilpotent in partial transformation semigroup, and in the product of nilpotent also in partial transformation semigroup. And then we will also in the 8th chapter talk about algebraic properties of the transformation semigroup, like the properties of rank, finding the minimal generating set, and their applications. And then we will now start talking about combinatorial and enumerative aspects in the 9th chapter, where we'll look at counting transformation in transformation semigroup. So we'll be looking at answering questions like how many elements are there, what is the number of idempotent in a particular semigroup, and then what is the number of nilpotent, and so on. And then enumeration of idempotent, nilpotent, and other classes of elements, like I said. Combinatorics of maps with restricted properties. In chapter 10, we will look at applications in automata and formal languages. So this is from the 10th chapter that we will start looking at where transformation semigroup can be applied. And then we'll look at application of transformation semigroup of infinite automata, and then we'll look at syntactic semigroup and language recognitions, and then we'll also talk about Krohn-Rhodes decomposition theorem, and then the 11th chapter will be talking about topological and metric transformation semigroup, and here we are trying to see the connection between topology and transformation semigroup. So semigroup of continuous set maps on a metric space or topological space, and then we'll look at semigroup of contraction mappings on metric spaces, fixed point properties, and dynamical systems. In the last chapter, we'll be talking about research problems, and participants will be given chance to make some presentation. So we will look at recent development and open problem in the theory of transformation semigroup, and also students will be allowed to present seminars on some selected topics or projects. So mostly we will select some of our research students, both MSc and PhD students, and we'll give them topic or their own topic they are already working on. We will give them room to make some presentations, and this is how we will go. And then finally we will we are going to have a final feedback on the sessions, and then a final review of the entire course. Thank you very much for being with us, and I look forward to seeing you in the second lecture, where we are going to start talking about transformations, defining partial, full transformation, and subsequently looking at structure of transformations in general. Thank you very much.